Alrighty, so I've been tagged a couple of times now in some posts on LinkedIn and Facebook and stuff like that about helping some people out with their render settings in Unreal, so I thought it's probably a high time I make a video about that. So I am in my Star Wars project from quite a while ago. I'm going to be going through and showing you all the tips and tricks and stuff like that to really push Unreal's render quality. So like these tips and stuff I actually found out I've been collecting for a while now. I actually found out most of these after making this project, not before, so that's why I never actually used them in this project. So let's get started, I guess. So first of all, we're using ray tracing in this project because, you know, ray tracing looks better for everything. So I guess we'll go through a number of these settings. We'll start with the project settings actually, and then we'll move on from there. So the first one is ray tracing. So if you don't know how to enable that, you just type ray tracing or ray and there it is. You'll also need to set your default RHI to DirectX 12 to get it to work. And you can tell if ray tracing is working because there will be this path tracing and this ray tracing debug options. There's a path traced version. Alrighty, so the next setting we're going to go and have a look at is our reflection captures. Now you're probably wondering, oh, why use reflection captures if we're using ray tracing? Well, I will tell you in just a minute. Essentially, we want to up this to like 1024, 512, 1024, a sort of a higher resolution. Next, we also want to go through and type exposure. So we just want to make sure enable pre-exposure is on. And we will enable in the editor and the extended default luminance range as well. Yep, that looks fine. And then lastly, we want to find the G buffer, like so, and the G buffer format, we want to either store the high precision normals or force everything to be at 16 bits. You probably don't need everything at 16 bits because chances are sort of the other things aren't actually 16-bit anyway. But so we're just going to turn on high precision normals. And so this is going to make sure it's reading back a higher quality normal than what it would normally do. So we're going to go ahead and restart that. Also, make sure, I think it's on by default, but the new render movie queue, pretty sure it's on by default. That's the only sort of out there plugin. Let's have a look if it is. Movie render queue, yeah, so I got it up there. What shot was I on? 5B? Yeah, see, it opens. I need to open the map first. Is it going? This project will not be available to patrons. Soz, but yeah, just how it be. One shots, 5B. There we go. Alrighty. So you may not notice a huge difference straight off the bat with that, but there's going to push things just that ever so slightly more. So next is time to render out a scene. So if you turn off real time, then Unreal will stop rendering at 120 frames a second or whatever you can achieve in the viewport. Your graphics card's going to calm down and everything's going to run smoother. Alrighty, so we're in the wrong version of Unreal. We're still in 4.25, so I've opened it back up in 4.26. And the reason I'm using 4.26 is there's a number of improvements to ray tracing and stuff like that. It makes it a bit better quality and higher performance. So we're definitely going to use that. Alrighty. So once you've set the settings in your project settings, we can go ahead and render this out. Although I forgot one thing. So we up the reflection capture resolution. So what we want to do now is just add some reflection captures into our scene. So I'm just going to add one in front of our characters here. and that'll be obvious in a second as to why. But ray tracing is a bit, how you going? Now you can actually turn down the ray tracing quality in inside here. So I can switch that to 1 bounce. And I can change the max roughness to like 0.2. I can switch the area shadows just disabled for now and turn up translucent objects and turn ray trace. Oh, that's right, none of them look good. Keep them undisabled, I guess. Yeah. So there we go, that's a bit better. Alrighty. And I'll show you why in a second that we can do that. The other thing is I'm going to turn off real time because we don't need. Oops, I turned it back on. I think there you go. Nice and noisy. Alrighty, so what we want to do is go ahead and open the movie render queue. We're going to add this shot into the movie render queue like so. Unsave config. Here we go. Perfect. Set our output. Where do we were putting that in here? In here. Say select and go all the way across and sequence name. Like so. Alright, so yeah, the tone curve thing isn't in here anymore. Alright, so what we're going to start with is our output format. So there is ProRes in here, and you can use ProRes if you want, but we're actually going to be using linear EXRs instead. So EXR sequence, and I'll tell you why that is when we finish rendering it out. But the basics is that we can get there is no data compression. There's in a linear EXR on a computer generated image, there is no such thing as a blown out highlight or a shadow with no information. So we have complete freedom when it comes later down the line. For the compression method, PIZ, like you can use no compression, but depending on the scene, you could get 100 megabyte EXRs per frame. So PIZ is probably the one I would recommend. Again, grainy image. Zip is more compression, but doesn't work if there's like lots of noise, like the ray tracing noise. Next, what we're going to do is deferred rendering. So there's a few different ways we can render it. So if we wanted to render lighting, the path tracing one is like experimental, so probably avoid that. We're just going to go deferred rendering, which is Unreal standard renderer. There's nothing else we can change in here. Next, we're going to go color output, and then under MISC, we're going to go disable tone curve so we can get proper linear EXRs. Under camera, we want to have the shutter on frame close. The reason by that is on frame close, motion blur will trail an object. On mid frame, motion blur, like the object will be in the middle of motion blur. So here's a nice diagram. This one's actually for Blender, but it's the exact same thing. The other thing is just double checking your post-processing you have motion blur on. Yep, 0.5, perfect. Next is our game overrides. So we're going to use the movie pipeline game mode. It doesn't really matter because we don't. If this was an actual game, that would make more sense because, you know, it's like we don't want it to actually play as though it's a game. We can tick the cinematic quality settings, although we're going to be overriding some of that. Use the highest LOD, disable streaming in LODs. We could change the view distance. That's fine. So texture streaming. So you have a few options. You have don't override, which means it'll load bitmaps, which means as textures get close to the cameras, it'll increase in resolution. That is probably not good because you can visually see them change. One option is to fully load all the used textures at their maximum resolution. That is going to destroy your VRAM unless you have like a 3090 or an A6000 with plenty of VRAM to spare. The last option is disable streaming, which means it'll load sort of to the highest resolution it think it'll ever need. So you're not necessarily going to have the texture at its maximum resolution, but you're never going to see it switch either. And that's the one I would recommend staying at. Alright, so next we are going to do anti-aliasing. Alright, so Spatial count is how many times it renders the same frame. Temporal sample count is how many. So like a temporal sample count will render different frame. It'll render sort of, so it's like, say it's on frame 35, it'll render frame 35.1, 35.2, 30, so it's like ever so slightly moved, and then that means it can generate more accurate motion blur, and you sort of get an accumulation of those things, and that's the one I would recommend changing. That has another sort of benefit, which I will talk to you, which I'll talk about in a minute. So 32 or 64 is the way to go. It'll give you a warning, so just override anti-aliasing and set it to none. Doesn't matter. Like temporal A, yeah. So you can't actually set it to any of. Oh, you can set it to FX. Essentially, this is temporal A anti-aliasing. That is okay. We can use render warm-up frames, and we can render 64 of those. So temporal accumulation on things like ray tracing needs time to accumulate enough data for that to actually make sense. Alrighty, so the last thing is the console variables. This is where things get like the tricky part, which is probably where you're going to find, you know, where I've sort of been collecting all my different things. So what we're going to start with, alrighty, so our motion blur quality, this is the quality at which it calculates motion blur, so we're going to set that at 4, which is really high. Our motion blur separable, this will render moving objects in separate passes, which doesn't work for a video game, but means that motion blur like won't smush into other things as much. Our depth of field quality, that one is going to just increase our depth of, you know, the quality at which it's calculating depth of field. Our bloom quality, that is the, you know, quality at which it renders bloom. Going to set that to 5. So these work great on a 3090. It may cause a DirectX crash on yours, so you may have to turn these down. Oh, except for the motion blur separable, that's a 1 or a 0. There's an R tone mapper quality, but when we disable the tone mapper, so we don't need that. Okay, next is our ray tracing commands. So our ray tracing global illumination, setting that to 1 will turn on brute force. Yeah, and then setting it to 2 is final gather. We have global illumination off in this scene. I don't think it looks good with these guys, so I'm actually not going to bother with this one. The next one is our global illumination max bounces. So that's why I didn't bother setting it in the post process, because we can override it with console commands. So I'd much rather the post process has settings that make it just run smoothly. So this sets how many bounces it calculates for the global illumination. So I'd recommend like 2. All right. Here we go. So our ray tracing reflections max roughness. This is the maximum roughness value for it to be, you know, have ray traced reflections on it. So setting it to 1 means everything in the scene, no matter how rough and non-reflective, will have ray traced reflections. Our max ray tracing bounces is going to be how many bounces it does. So this is what gives us ray traced reflections inside ray traced reflections. Our ray traced shadows, reflection shadows, this one, set it to 2. This means it'll sample area lights as though they're area lights. So by default, to save time, Unreal samples area lights as a spotlight. So setting this to 2 in here means that it'll actually consider it as an area light. And all of these does override the post process. That's what, so they're like disabled here. That's what, see, hard shadows or area shadows. Alrighty, so the other one, which I didn't write down, so I'm gonna write it in now, is our ray tracing reflections. Oops. Here we go, reflection captures. So on the last bounce of a ray trace reflection, it's actually just going to sample black, which means your reflections will look a bit dark. So by having the R ray tracing reflection set to 1, that means on the last bounce it's going to sample the reflection capture in this scene. So essentially it's going to be like it has a HDRI, and that's going to make just your shadow, your reflections a bit brighter and everything a bit brighter, which is nice. Alrighty, moving on. R ray tracing reflection samples per pixel. This is how many samples it takes per pixel. Now, because our anti-aliasing is set to 64 frames, 64 samples per frame, then whatever this value is, times it by 64, and that's going to get you what each frame actually gets. So like setting this to 2 means we're actually going to be taking 128 samples per frame for reflections. And so if you have a not as good ray tracing card, then setting this to a lower value and simply upping your your temporal sample counts is going to be the same as having that as a lower value and this is a really high one. So that's a way to avoid crashes, is keep this low and keep the anti-aliasing temporal samples high. These guys are really noisy, and in my actual one I didn't do enough samples, so they were flickering, so I'm going to keep this really high because the 3090 can do that. Are ray tracing shadows per let me read it. Are ray tracing shadow samples per pixel? This is how many samples a shadow gets. I'm just going to leave it on probably 2. Oh, not 23, 2. There is another one which is R ray tracing global illumination samples per pixel, which it looks like that. Same thing for global illumination. We're not using global illumination, so we won't be using that. Okay. Next, 2 more things. Alright, so the temporal anti-aliasing can make everything look a bit soft, which I'm not a big fan of. You have 2 options for this. My recommendation would be to do this in your editing software. That way you have a lot of fine tuning over it. But if you don't want to, for whatever reason, or you want to include this in like a game, the R tone mapper sharpen is the command to add a sharpen effect to it. This can be beyond 1, so you can set it to like 2 or 1.5 is probably a good value in my opinion. So that's something to keep in mind. The other thing is Unreal 4.26 has a new experimental temporal anti-aliasing algorithm, which is R temporal AA.algorithm 1. It's supposed to be better and faster and more accurate, so we can set that here. I haven't actually done side-by-side comparisons yet to see if it actually is better or not. A few other ones to keep in mind in case you need them is, I'm going to paste them in Notepad off of my documents. Alrighty, disable temporal effects. These are sort of the accumulation of render samples over time, which helps with noise, so you need to disable that for if you're using the tile rendering in Unreal, which I'd recommend not using because there's a lot of things that doesn't work with it. But they're the commands for that. Let me make them a bit bigger. And then if you need to disable any of the denoisers, ray tracing denoisers, they are the codes for that as well. You know, I might actually post all of the codes in as well. So there's your tone mapper sharpen and your temporal AA. And here is the recommended render settings. So there's your here we go. Motion blur, depth of field, bloom, tone mapper, global illumination, reflections, reflections. And then here is the sample ones, which is samples per pixels. They're all ended samples per pixel. Oh, these ones are max bound. Alright, hopefully they were on screen long enough for you to pause the video and look at them. I may stick this text document somewhere. I might just stick it on my Patreon and then just make the post free or something. I have them written down elsewhere. Alright, so now we have all of our settings. This will produce high quality results, but be aware that this is just going to blow your render time. Like, this is not real time. This is gonna just like destroy render times. So I'm gonna you can save this as a preset, and I recommend doing that. So like we'll call it high quality RTX or something. Save, accept. All right. So the last thing we can do is the render local or render remote. Always do render remote. Render local is faster to load up. However, if render remote is good because if it crashes during rendering, you won't have to reopen all of Unreal. And the other thing is, if it is going fine, you can just close Unreal and have the remote render running. We have real time off, so the only because we've got real time. If you leave real time off, then Unreal isn't actually taking up any GPU resources, just VRAM. And on a smaller card, you know, you would probably want to close Unreal so it unloads it, so it's not loading textures twice, basically. In my case, I've got plenty of headroom for that. So we're going to hit render remote. It's going to load up. Ever so slowly. Oh, and we got a crash for some reason. Why? Let's try that again and try and figure out why it was crashing. I think this scene was doing it before. Oh, it's the, yeah. Alrighty, well, let me think how to turn that off. That's not any of the render settings that's crashing it, it's this Steam audio. So this project I used Unreal's own audio system to mix audio. How do I turn it off? Is that enough? Oh, there we go. Nice and slow. So another thing to note is this little viewport is a little misleading in terms of the camera shot. I think it zooms in slightly on it. I mean, it says low quality anyway. So I will see you once this is done rendering. Alrighty, so that took a while, but it's finally finished. So we have somewhere there. Yep, so we have a bunch of EXR files now of our animation. So obviously don't render out at that quality level until you're happy and it's like your final render. Just quickly finishing up, I'd recommend using Davinci Resolve for editing the EXR files, simply because it's a lot better at doing EXR files than you know, something like Premiere Pro. So I use Resolve. I have the studio version of Resolve. I use that usually for my animations, and then I use Premiere Pro for editing these tutorials. So if you navigate in, this isn't really going to be a Resolve tutorial, but if you can navigate to your folder in the media storage, it's going to show up the EXR sequence as a video file, so you can import that. So it looks really contrasty and not what we saw in Unreal. So if we enable color management, so that's the cog at the bottom, color management, and we're going to switch to ACES CCT. And then the out transform. Yours is probably going to be sRGB, but my monitor has been calibrated to Rec 709, so that's okay. So that's going to look different again. Then we right click. So Unreal's rendering pipeline closely matches, but isn't exactly ACES CG. But if you select ACES CG, you're going to get a pretty close result. So now we can stick that on the cut timeline. Boop. And that's going to give us, you know, our high quality... Oh, I can't play back an EXR file. Yeah. Where is generate optimized media? Obviously, playing back an EXR files isn't easy because it's... How big is this footage? It's 151 frames and it's almost a gigabyte. That's ridiculous. Use optimizer available. Good. So now, there we go, nice and high quality. So I'll put that at the end just so we can see the quality level, but that is, you know, superb quality for Unreal. Nice reflections in there. A little bit of, can't tell if my monitor's dirty or what. I don't know. Oh, maybe that's just the texture on the Stormtrooper. Oh no, it doesn't seem to be moving. Alright, I don't know what that is then. But yeah, there we go. And then obviously being XR, we can go as absolutely as crazy as we want on the color grade. Although this actually looks not half bad as is. At least I can't think of any adjustments to make. Yeah, awesome. So as I said before, this I probably won't be providing this project just because it's sort of a personal project. But there you have it. Alright, so thank you for watching.